All right, so here are the notes that I said I'd have up for you guys. This is for my Algebra 2 class and my Algebra 2 honors class. So both of you guys went over the same objectives today, being able to perform basic operations with two separate functions and make a new function out of those. Second objective, be able to state the domain of a new function of the new function created. So basic operations, just to go over this again, basic operations were adding, subtracting, multiplying, we'll use an X for multiplying, and dividing. Functions, basically make sure if there's one input, there's one output, but we're not going to worry about that because I will be giving you functions, and all the problems you guys will be working with, you'll get functions back out. Domain, just a little recap of domain. So we went over that in class. So just a little recap of the domain. The x values that work with the function are your domain. So that's what you're allowed to plug in. So what I told you guys was the main things that you should be looking out for are dividing by 0 and look out for even roots or rational exponents with even denominators of negatives, because even roots of negatives produce complex numbers, and we don't want that. So we did these in class. I'll go over these. So the first one, this one over here, there are no roots, so we don't got to worry about the whole even root thing. Now, what we do need to look at is the division part. So you guys can see this division line. Since we are dividing, you want to make sure you do not divide by 0. So looking at the bottom expression, the denominator, it's 2x minus 8. So I know that the entire expression of 2x minus 8 should not be 0. So that should not be 0 because you should not divide by 0. Now, to figure out what actual x value, because all we're worried about is the x value, that you're supposed to have, you got to solve this out. So you're going to add 8, so you're going to get a 2x. Shouldn't be a positive 8, sorry. 2 times x shouldn't be 8, so you're dividing by 2. X should not be a 4, which makes sense because if you plug in a 4 here, so for this x right here, if you were to put in a 4, 2 times 4 is an 8, minus 8 would be the 0, and you should not divide by 0. So to write down your domain, so I'm going to erase all of this. Now that does not mean you should erase that. I just ran out of room, so I want to erase it so you guys can see it more clearly. So we know that x can't be 4. So the way you would write your domain, or the way I want you guys to write domain in my class, is domain is going to be all real numbers. So the symbol for that's a capital R with an extra line through it, with a comma. X should not be 4. So that's read as domain is all real numbers, but x cannot be 4. All right, looking at the second one, domain here, we have an even root. That's your 6th root, even root of x minus 8. Now, depending on what you guys plug in for this x value right here, inside of the root could be positive or negative. So what we're going to do here is this. So we look at what's inside of the root, which is x minus 8. So you write x minus 8. That's the radicand. So x minus 8 should be positive or 0. It could be 0 also. So to say it's positive, you say x is greater than 0. That means it's positive. But since it can be 0 also, because you are allowed to take the 6th root of 0, it can be equal to also. So now this part is showing us what your x's are allowed to be. X's are allowed to be greater than 0. Not the x's, but inside of the radical is allowed to be bigger than 0, which means it's positive. It's also allowed to be 0. So we took the x minus 8, set it greater than or equal to 0. Now we just solve this part. So you can do plus 8, plus 8. Okay. Those 8's go away, so x is greater than or equal to 8. Now if you check that when you plug it into here, if you guys pick a number that's greater than 8, like a 10, 10 minus 8 is a positive 2, and you can take an even root of a positive 2. Now if you pick a number that's smaller than 8, so let's say a 5, so you pick a 5 which doesn't meet this requirement. If you pick a 5 and you plug it in, that's going to be 5 minus 8, which is a negative 3, and we don't want negatives. So the x is greater than or equal to, go away, okay. X is greater than or equal to 8, that is your domain. So you'd write domain, I'm okay if you guys write D. Domain is not all real numbers. It's only the numbers that are bigger than or equal to 8. All right. Okay. So that is how you guys find domain. That's not the main point of today, but you guys seemed very confused when I was going over domain, so I figured I'd do a little bit here to show you about that. This next case, this is an x squared. All right, so it's an x squared. That's not a root, so I don't got to worry about it because it's not an even root. That's a power, not a root. And there's no dividing going on, so there's basically no restrictions I really got to worry about, which means that you can plug in anything for x. Positive, negative, 0, doesn't matter. You just square it, multiply it by 7, subtract the 9, and you'll get an answer. So there's no rules that are really broken with that. So with this one, you would say your domain is basically all real numbers. All right, so moving on. Okay, these two examples I believe we got through in most of the classes. We'll go ahead and go over it again though. So this one, first off, your f of x. So I'm going to do this in green. Basically, you're taking this function and then you're subtracting the second function. So the f of x, let's go ahead and do the framework here. Plus, do the other one in red. All right, so we're just filling it in. So f of x is a 2x minus an 8. So what we did is we took this f of x and we rewrote it as 2x minus 8 since we know that they are the same thing. So same thing with the g of x, but g of x is kind of longer. So 3x squared minus 7x plus 10. All right, so the first step here is that you need to drop your parentheses because we are adding, which basically means you're just combining like terms once they're out of the groups. Since they're within the group, you do have to drop your parentheses first to get them out of the group before you combine them. So it's going to be a 2x equals 2x minus 8 plus, and then none of these change signs since you're adding, so you're just going to multiply by a positive 1. Get an x squared minus 7x plus 10. Now you're going to, whoa, that's a 0. There you go. Now it's a 10. So now you're going to look at like terms. We got 3x squared, no other 3x squareds, or no other x squared. So you just write 3x squared down, cross it off so you don't confuse it again. Next one up, as far as degrees go, 2x, linear terms, a negative 7x and a positive 2x. You're going to subtract those, get a negative 5x, negative 8, positive 10. So we're going to get a plus 2. All right. No other like terms. That is your function, your new function. Now, we got to look at the domain here. So if I look at the original domains, it has to be within both of the original domains. Now, looking at this one first, okay, that one has no roots, has no division going on, so that's just going to be all real numbers. Remember, the two things you should be looking for are roots, even roots of negative numbers, or just look out for even roots, and then you can figure out how to make them negative later on. And denominators or fractions, which is not the case in either of these. So that means that these are both all real numbers. Last check is the actual new function itself. That doesn't have roots or division either. So your domain, there's no restrictions on it. Nothing will mess it up. It's just all real numbers. All right. Sorry if I'm going kind of fast. I said I would try to get this up. I think I said by 6 o'clock. And I want to try to get out of here by 5. And you can read my clock, and it's almost 5. So next part. So g of x minus f of x, two groups. All right. So try this out. G of x is going to be, order does matter with subtraction, so make sure you write the 3x squared minus 7x plus 10 first. Remember, the domain of that first one is still all real numbers. It didn't change at all. 2x minus 8, that domain is still all real numbers also. Now we're going to put them together. My equal sign there. All right, so we got to drop the parentheses. 3x squared minus 7x plus 10. All right, so there's a negative 1 in front of there. So to get it out of the parentheses, you got to multiply. So it's a negative 2x plus an 8. Go through again, find your like terms. 3x squared, once again, has no other like terms like it. So that one's gone. Look at your linear terms next. Negative 7x, negative 2x. Same sign means you add. So it's a 9. More negatives. Negative 9x. 10 and an 8. It's plus 18. No like terms, keep it like this. Your domain consists of all real numbers again. No dividing, no even roots, so domain is everything you can put in, all right, as far as real numbers go. Remember, we're not doing complex. Complex was with the quadratics section, and we're not really too worried about that. All right, so this is where most of the classes didn't really get past, so I'll try to go into this one more detailed. Excuse me. F of x is 2x to the 1/2 plus g of x, which is negative 6x to the 1/2. Okay, you only have one term in each of these. So technically you don't really need the parentheses, because parentheses is to group things. But if you have a group of one, you don't really need parentheses around it. So since this is just one, technically you can put a 1 out here and distribute, but it's just going to be a 2x to the 1/2. Same thing here. So that's just going to be then plus a negative is just going to be minus 6x to the 1/2. Now this goes back to like terms. We got x to the 1/2 here, x to the 1/2 here. That means those are like terms. So you can do one of two things. Either you know they're like terms, so you just combine the coefficients, or you can look at x to the 1/2, factor them out, and do 2 minus 6. What we're doing in the class, in basically all the classes, were we were saying they're like terms, so you can put them together. So 2 minus 6 is a negative 4x to the 1/2 power. And that's your new function. Now, the domain part. If we look at the original equations, the domain of the first one, 1/2 power, right? So that's the same thing as the square root of x. Now, we just said that we cannot have negatives inside of the square root, inside of an even root, because we don't want any imaginary parts. So you want to take this inside part and define it as x is greater than or equal to 0, because we don't want negatives. There's nothing to solve there like we did on the previous example, so that's your domain of the first one. The second one, you got the same deal here. You got x to the 1/2, which is the square root of x. We're not really too worried about the 6 because that's on the outside. That's going to be multiplied on later on. All we're worried about is the inside of the root, so that's going to be x is greater than or equal to 0 also. So since they both have the same, that doesn't really change the restriction. If I say that I need all my answers to be positive and 0, or all the x values you can pick are bigger than 0 or equal to 0, and then saying it a second time doesn't really add anything to the list or take anything away from the list, so that stays the same. Now, as far as our final answer goes, if we look at the final answer, when we put it together, exact same situation. Right? So your x's should be bigger than or equal to 0, because we don't want negative. So that's your domain. Since all three of them are saying the exact same thing, they don't have to say the exact same thing, but remember, we're taking a list of numbers, all real numbers, and then we're kind of cutting that list down. So for the first one, it said no negatives. Okay, so I cut out all the negatives. The second one said no negatives again, but they're already cut out, so who cares? Well, I guess you should care, but still. Third one said, hey, no negatives again, so it just repeated itself 3 times. So you can say, okay, I get the point. No negatives. There you go. Domain is greater than or equal to 0. All right, same for the second one. Let's see here. We got our, need an equal sign over there. 2x to the 1/2 minus negative 6. Oh, wait, I got that backwards. All right, so hopefully I remember to put the notation to say, hey, don't do that. All right, so negative 6x to the 1/2. See what happens when you rush? You should go slower. Yes, I'm talking to myself. And f of x is 2x to the 1/2. All right, so same thing as before. These are only one term polynomials, so you actually, well, you can just multiply a 1 in, you get a negative 6x to the 1/2. Now, on this other one, you're multiplying a negative 1, so it does change signs. Negative 2x to the 1/2. All right. Next part. So negative 6 minus 2 is a negative 8x to the 1/2. And once again, we already know that our original functions had the domains of X's were greater than or equal to 0 for both of those. Let's see if our new function takes off any more values, and it doesn't because it's just another x to the 1/2 power, which is the root of x, which means that still you want this inside part to be 0 or positive numbers. So your domain, once again, told you 3 times in a row that x should be greater than or equal to 0. All right, so just to see how many of you guys actually watch this, in class, somebody should ask me the question as far as, okay, all 3 functions told me to get rid of the same values. So what does it look like if your functions start telling you to get rid of different values? So let's see who asks me that. And there might be extra credit involved. We'll see. All right, so this is a U-try, pair share. Given the function below, first add, then subtract, find the domain of the resulting functions. Alrighty, so since this is going on 16 minutes and it's 5:05 and I gotta get out of here, we'll stop after I finish these ones, and then yeah, we'll finish the rest of these in class. So just make sure you get these examples down now. So we'll get this one done. All right. Now, since we know we got to go back later on and find the domains, we might as well look at this right now. We have the 6th root of x. So since there's just x inside of there, we set our x, the inside part, greater than or equal to 0. There's nothing to solve out. If that said x plus 5 is greater than or equal to 0, you'd have to subtract 5. But it doesn't, so you're done. That is your domain of the first one, the f of x. Domain of the second one, exact same situation. You have an even root. You want the inside part to be bigger than or equal to 0 because you do not want negatives here. We don't want complex numbers. Okay, so there you go. That didn't take long. And let's go ahead and add these and then subtract them. What I suggest you guys do is pause the video right now, since this is supposed to be a pair share, and try this on your own. After you try it on your own, push play again, and then see if you got the same thing as me or not. Okay? Okay, so, oh yeah, one more thing. You will notice that this one just says g plus f. That's another notation that they use to say you're adding functions together. It doesn't have to say g of x plus f of x. The g part and the f part do imply that you're talking about the function as a whole. So g plus f is going to be, your g part is 7 6th root of x plus your f part, which is 4 6th root of x. So looking at these, it's still, we can't combine them until we get them out of parentheses, but these are only one term each. So you just take down the parentheses, basically. Plus 4 6th root of x. All right, now looking at these, we do have like terms here. We have 7 of these 6 root x plus 4 more of these 6 root x. So if you got 7 of something, this is the something, plus 4 more of the same something, you will have 11 of that something. And that something happens to be 6 root of, not 6, erase 6 root of x. All right, so 11 times the 6 root of x. Now notice again, this part down here is basically telling us the same thing as the pieces up here, which means that you have a third part telling you the same domain it was talking about before. So this inside part, this x, well, this is your answer first off. Okay, that's what happens when you add them. So this inside part, x should be greater than or equal to 0. No solving involved. That is your domain. You stop right there. Okay. Next part, f minus g. So you take the f part. So the f part is 4 6th root of x minus the g part, which is 7 6th root of x. The domains are still the same. And let's see here, take it out of the parentheses. Equals equals 4 6th root of x. So you got 4 of these things minus 7 6th root of x. So 4 6 roots x minus 7 6 roots x. Okay. Tongue twister there. Okay, 4 minus 7 is negative 3. sixth root of x. There you go. I knew I could talk. All right. Now, with this one also, the x is on the inside of a even root. That means you take the inside part, which is x, set it greater than or equal to 0. That's your domain. Your original domains were the exact same, so it told you 3 times in a row that your x's have to be positive or equal to 0. So your domain is x is greater than or equal to 0. Box your answer. And yeah, there you go. That's how you add and subtract certain types of functions. Now, tomorrow we're going to start off with this. Find the product and quotient of the two functions below, then find the domain. So I'm not going to go over that right now. We're going to do that in class tomorrow for some of you. Some of you guys are going to be the next day, depending on what your schedule is. All right, so hope this helped. Okay, bye-bye.